Okay, let's dive into this. Have you ever asked an AI a question, maybe something super complex about history or writing some code, and it spits back an answer that is just completely, demonstrably wrong? But the really fascinating and honestly kind of terrifying part isn't just the mistake itself. It's the absolute unwavering certainty it uses. I mean, it doesn't hesitate. You don't get a maybe or a perhaps. It states total nonsense like it's the fundamental law of gravity. Well, today's explainer is all about exactly that phenomenon. We're going to unpack the underlying mechanics of machine confidence, why the systems we rely on literally every single day are faking it, and how an initiative called Codatta is actually trying to measure that confidence right at the data source. When you look out at the tech landscape right now, it's wild. We see a massive array of completely different applications. You've got large language models writing college essays, financial algorithms moving millions of dollars in a blink, and risk assessment tools deciding who actually gets a mortgage. On the surface, these seem like totally isolated systems, right? Doing fundamentally different jobs. But if we peel back the layers and really look at the foundation, we find that despite these wildly different outputs, many of the systems we depend on share a massive invisible problem. It's a hidden flaw that most folks are completely oblivious to, yet it dictates the reliability of literally everything these machines produce. Let's ground this in some high-stakes reality. Think about these examples directly from our source material. Number one, a credit model predicting default risk. This is a system deciding a real person's financial future. Number two, a trading engine flashing a massive buy signal on the stock market. And number three, an AI generating a factual answer for a user. In every single one of these scenarios, the machine is projecting total, absolute certainty. The credit model doesn't say, I'm about 60% sure they'll default. The trading engine doesn't go, well, I have a hunch we should buy. No, they give definitive directives. They project absolute certainty. But as we're about to see, that certainty, it is entirely unfounded. And that brings us to our first section, the illusion of certainty. Let's look at how machines are faking this confidence. The hard reality we have to confront here is that none of these advanced systems, not the credit model, not the trading engine, not that conversational AI, none of them actually know how confident they should be in their own outputs. The certainty you're experiencing is basically a mirage. So, why? Take a second and just let that sink in. Why don't they know? I mean, if we can build a machine that processes millions of data points in a fraction of a millisecond, why can't it just tell us how sure it is about the result? We really need to shift our focus away from the symptoms we see on our screens and drill all the way down to the absolute root cause of this whole issue. Let's explore exactly what that is in Section 2, the hidden flaw, missing data, which leads us straight into Section 3, flattening the signal. Now, what's really interesting here is how equal training weight fundamentally distorts reality. See, when a model trains, it acts like a giant vacuum. It's just sucking in vast amounts of text, numbers, variables, but completely without any layer of confidence scoring attached to that data. So think about how this plays out. You have a meticulously researched, peer-reviewed source representing years of rigorous study and verification, going head-to-head with the totally unverified claim, maybe just some random off-the-cuff comment scraped from a message board. Because the machine lacks any built-in confidence scoring, it just absorbs both and treats them as fundamentally equal. It's shocking, really. They often end up carrying the exact same training weight. Mathematically, the machine values the random internet claim just as much as the peer-reviewed science. And let's take that a step further. The machine takes expert judgment, literally the result of a professional's lifetime of experience in a specialized field, and puts it right next to pure, blind, random guessing. Without a system in place to score the reliability of where that information came from, these two diametrically opposed inputs get completely flattened into identical signals. The machine simply cannot distinguish between a master of the craft and someone just throwing darts at a board blindfolded. So it ends up building its entire worldview on this incredibly unstable, totally flat foundation. That takes us to Section 4, dangerous overconfidence, and the real-world result of that unstable foundation. This whole flattening of data, it's not just some abstract academic puzzle. It has incredibly severe consequences out in the real world. When you train a system on flattened data, you inevitably breed a system that outputs flattened answers. Answers totally devoid of nuance, hesitation, or doubt. We really need to reframe how we think about this term entirely. Overconfidence here isn't an AI developing an ego or some human personality trait. No, it is a deep structural machine learning flaw where a system sounds certain despite an incredibly unstable foundation. And the problem is, we humans are psychologically primed to trust confident voices, which means we are at serious risk of blindly handing our finances, our health, and our biggest decisions over to systems that are projecting a really dangerous illusion. So, the crucial point is, how do we actually break this illusion? Welcome to Section 5, Fixing the Source, and the Codatta Intervention. Instead of trying to slap a Band-Aid on the outputs or build some filter after the AI has already been trained, Codatta recognizes something fundamental. If the problem starts with the data, the solution has to start right at the data source itself. Let's walk through exactly how they do this. Step 1, they actively attach confidence scoring directly to the data before the machine ever even sees it. This restores that crucial dimension of reliability that got flattened out earlier. Step 2, they rigorously validate the contributors. This ensures that expert judgment is mathematically weighted much higher than a random guess. And step 3, by doing all of this, they actually allow the system to measure uncertainty. Instead of a flat, meaningless signal, the machine learns the nuanced landscape of what is definitively known versus what is merely just a possibility. Which brings us to our final section, building human trust and creating reliable confidence. Fixing this data layer is about way more than just making algorithms slightly more accurate. It fundamentally redefines our entire relationship with technology, and this brilliantly illustrates our core thesis for today's explainer, measuring uncertainty instead of faking certainty. See, Codatta gives these advanced systems the actual architectural ability to know what they don't know. It shifts the entire paradigm from an AI that just confidently hallucinates answers to an AI that can transparently tell you exactly how reliable its underlying data actually is. It transforms machine confidence from a dangerous illusion into a real metric, something we can genuinely, safely rely on. I want to leave you with one final thought to carry with you long after this explainer wraps up. If a machine can't measure its own uncertainty, why should we ever trust its certainty? The next time a credit model, a trading engine, or even just a conversational AI gives you an absolute definitive answer, ask yourself where that certainty is actually coming from. Because until confidence is measured at the source, remember, a confident machine is not necessarily a correct one. Keep questioning, keep learning, and thanks so much for joining me today to explore the hidden mechanics of machine confidence.